In our last screencast, we used manual methods for finding the current flowing through the various branches of the circuit. In this screencast, we're going to apply matrix methods for accomplishing the same thing. Hopefully, we'll find that these methods will result in a less tedious approach to finding our solution. To begin with, we're going to define two current loops, loop 1 and loop 2. I'm just going to circle these so we don't get them confused with our resistors. Now, it's imperative that we define the loops in the same direction. These loops are both going clockwise. We can't have one going clockwise and the other counterclockwise. They could both go the other way, but they have to be in the same direction. Now, I chose the loops to be inside the circuit. We could also have a loop going around the outside of the circuit. Any two of the three would be fine. Okay, so you could have the loop going around the circle instead of one of the interior loops. So where do we begin here? Let's take a look at loop 1. Okay, so we're going to write down loop 1. And we're going to apply Kirchhoff's rules to loop 1. Kirchhoff's rule says that, or the loop rule anyway, says that the voltage drops across the entire loop must be 0. And so if we look at starting at the power supply, as we cross the power supply, we have a positive drop from 0 to 12. Then, as we cross the resistor element, the 4 ohm resistor, we have a drop, a negative drop, because the current is, the voltage at node A is less than what it is at node C. So we have a drop across the 4 ohm resistor to 4I1. We then proceed inside the loop across the 6 ohm resistor, and we have another drop of 6I2. And then the voltage is recombined down here. That would be I1. And so we have a final drop of 5I1. Oh boy. And the whole thing needs to add up to 0. So I'm going to have to move this over. Oopsie poopsie. I'm going to have to move the whole thing over. Let's put it down here. Okay. And then we're going to set that equal to 0. Okay, I didn't leave myself enough space. Okay, for loop 2, we're going to apply Kirchhoff's rules again. And we'll start at the top, up where A is. And we see that we have I3 going across the 7 ohm resistor. So we have a minus 7 I3 drop across there. I3 continues past the 3 ohm. I could have combined those, I suppose. Minus 3 I3. And then it loops back up through the 6 ohm resistor. And since it's going, the current is going, I guess, backwards or forwards, however you want to say it, we have a positive drop of I2, 6 times I2, and that all adds up to 0. Okay, so we've applied our two loop rules. Now we're going to apply the node rule, sometimes called the junction rule. So the node rule states that, let's look at node A, the current entering I1 is equal to the current leaving I2 plus I3. Okay, and so now we have 3 simultaneous equations and 3 unknowns, and we can proceed to solve this. Sorry about that. Let's shrink up these equations a little bit. We'll group them and shrink them. Okay. So our next step now is to use matrix methods to solve this system of equations. Much easier to use those in a calculator. So we're going to combine them in a different form. Let's add them up together. Let's put the 12. I want this all to for this one here. I want the oops. want the current, let's see, I want to express it in this form. I'm going to put I want the 12 to be on the positive side of the equal sign, and so I'm going to make 4 I1, that's this term, and we're going to combine the other I1, get that over here, plus 5 I1, we're putting them on the other side of the equal sign here, plus 6 I1, that's going to be equal to 12. Okay. Next we'll look at loop 2, and we'll combine these two right away. So we have minus 10 I3, should have done that with the I, and we have plus 6 I2, and that's all equal to 0. And then finally, by rearranging our equation for the node rule, we have 1.0 I1 minus 1.0 I2 minus 1.0 I3 equals 0. Okay. So we've simply taken what we had before and re-expressed them in a different form. Okay, now this will make it a little bit easier for us to do our final step, which is to put this into a matrix form. We're going to define the matrix A. I need my pen. To consist of a series of rows and columns. In our first row, we will have the elements for I1, our first column, I should say, then I2, then I3, and then we're going to have a solution column. Okay, and so we are going to put the coefficients of our equations into this matrix. Starting with the coefficients for I1, we can combine these two terms, and we have 9. Do I have a mistake here? It should be I2. I just wrote it down wrong. Okay, for I2, we have a 6. We don't have an I3, and our solution is 12. Okay, so it's 9, 6, 0, and 12. Our second equation, we don't have an I1, so we have 0. I2 would be 6, that's this term here. I3 would be 10, minus 10, and our solution is 0. And then in our last equation, we have a 1, a minus 1, a minus 1, and a 0. Okay, now I'm going to shrink this up a little bit, and then I'm going to explain what we do next. Okay, so let's group this, and then we'll shrink it down. Now, the next step involves getting our calculator out. I'm going to go get my calculator, push the on button, and we go to second matrix. And then you can pick any one you want. I'm going to pick A. So we enter all of these elements into our matrix. Okay, so we first, oops, I'm sorry. Let's see, second matrix. Oh, scroll over to edit and then hit enter. And now we can enter the elements. We want to enter a 3 by 4 matrix. And so we enter 3 by 4, and then we insert the elements. 9, enter, 6, enter, 0, enter, 12, enter, 0, enter, 6, enter. Be sure you use the negative key, negative 10, enter, 0, enter. Now do the last line, which is 1, enter, negative key 1, enter, negative 1, enter, 0, enter, and then second quit. What we have done is we've gone to the matrix, whoops, matrix function in our calculator, and we've entered in this value of these values for creating our matrix A. Our next step now is simply to analyze this. And so what we'll do is we'll go second, matrix, and then scroll over to math. Math. Before we went to edit to create this, now we're going to go to math to analyze it. And then scroll down until we get to the function rref. Okay. And then simply hit enter. Okay. Now the next thing we have to do is go second matrix. We go second matrix, and then we select A. Okay, then we select A. And we do that by simply scrolling down to whatever. We don't have to put it in A. If you put it in another one, that's fine, but don't forget which one it was. And then hit enter, and we get RFA. I always put the closed parentheses on there. Enter, and we get the following solution matrix. One is augmented matrix, I guess. 1, 0, 0, 0, 1, 0, 0, 0, 1. And then our solutions fall out like this, 0.941. We can round that up to 2. The next one would be 0.588. These numbers look familiar from our previous analysis. And then the last one would be 0.353. What we've done now is we've found the solutions to current I1, current I2, and current I3. Okay, 3. And I don't know if you're going to agree with me or not, but I think this is a little bit easier method than what we have done in the past. It's a manual method. Let's see, group. Okay. And so in a few short steps, first by defining or going through the loops and defining using Kirchhoff's laws, we can set up these equations. And then we could probably go right from there directly to creating this matrix if we wanted to, if you're once you get familiar enough with it. And then it's just basically a 3-step process. Put that into your calculator and generate the solution matrix right here. All right, so we've done both the manual method and the matrix method.